This is topic 15-3, Analyzing Quadratic Functions, Day 1. Our essential question is, how can I analyze graphs of quadratic functions and draw conclusions? So first we must do our bell work, which is on the Making Connections worksheet. It's the last two problems on the worksheet. Problem number 5. Which point of the grid satisfies the conditions where x is greater than 5 and y is less than -1? So we want to find out what are the ordered pairs that represents the points that are given. W, if we count over, starting at the origin, W goes to 1, 2, 3, 4, 5. X coordinate is 5. Y coordinate, we're going down 2, so it's -2. X, the X coordinate is 5. The Y coordinate, we're going up 2, so it's +2. Y, starting from the origin, 1, 2, 3, 4, 5, 6. X coordinate is -6. We went to the left, and then we count up 1, 2, 3, 4, 5, and say +5 in the Y direction. Z, starting from the origin, we count 1, 2 to the left, so it's -2, and we're going 1, 2, 3, 4, 5 down, so it's -5 in the Y. So now we're going to see which one of these points meet the conditions that are given where x is greater than or equal to 5 and y is less than -1. So our x coordinate is the first number, y coordinate is the second. And A, our x is greater than or equal to 5, it's equal to 5, so it's okay. B, it's equal to 5, it's okay. C, x coordinate is -6, that is not greater than 5 or equal to it, so C is out. And then D, -2, is not greater than or equal to 5, so D is out. Let's check our y values. Y must be less than -1. -1, -2 is less than -1, so that works. However, +2 is bigger than -1, so B does not work. Our correct answer is A. Number 6, we're asking the same question, except this time they do give us the ordered pairs. So let's look at the ordered pairs. We need where x is greater than -2. So another way we can do this is looking at the x coordinate. Here's my -2. I want all the values of x to be bigger than that. So now let's look at the numbers. F is -5, x is -5. -5 is not bigger than the -2, so F is out. G says 5. On my axes, there's 5. It is possible. It is bigger than -2. H, the x coordinate is 2. It is bigger than -2. J, the x coordinate is -3. That is not bigger than -2, and so J is out. So we've gotten rid of these 2 points using our x value. Our y value, let's make that a y, must be less than or equal to 3. So if I'm looking at my y-axis, I want all the y values to be less than that point. So I'm going to be looking at values that are below that. Let's look at G. Y is equal to -3. So yes, -3 is below that. That works. H, y is greater, or y is 4. That is bigger than 3, so H is out. Our answer then is G. Here are the answers to assignment 15-2. You may pause if you need longer in order to check your assignments. It's helpful if you have your previous day topics out so you can refer back to them if you need some help. Because notice we are still dealing with the quadratic function. From your previous topics, you should be able to tell me what's the equation, what's the vertex, what's the domain, and what's the range. You can probably tell me the maximum or min because some of you have figured that out. The only thing that is new is this axis of symmetry. So we know from our previous topics that the equation is y equals x squared, or you could write it in function notation as f of x equals x squared. We also know our vertex is at 0, 0, meaning it goes through the origin. And here's where you may or may not remember. If it is opening up, that vertex is the lowest point on the parabola, and therefore it is a minimum. If it was opening down, it would be a maximum point on the parabola. So in this case, our vertex is a minimum. I'm going to skip the axis of symmetry and come back to it. We know from our previous notes the domain is all real numbers. We can use all those x values in order to graph. And the range from our previous notes is y is greater than or equal to 0. That range depends upon the y-coordinate of your vertex. If the vertex is a minimum, then 0 is the lowest number it can be, so all the other y values must be bigger than the 0. Now let's talk about the axis of symmetry. I want you to get a different colored pencil or highlighter, and you're going to start off highlighting the origin. Then you're going to draw a vertical line through that point. Let me rephrase that. You're going to highlight the vertex. Use the right vocabulary. We're highlighting the vertex of the parabola and drawing a vertical line through that vertex. So that represents your axis of symmetry. It is a vertical line through the vertex. Now, in order to name the axis of symmetry, it is a line, so we need to name the line. Let's recall, I'm going to shift mine over for a second, get it off of the y-axis so we can see it a little bit better. When we've had a vertical line before, we noticed that it only touched the x-axis. So that means our equation for it had to be x equal. Did not touch the y-axis, it only touched the x-axis, so it's x equal, and it would be x equal wherever it crosses the x-axis. So when I put my axis of symmetry back, going through the origin, we see that this vertical line touches the x-axis at x equals 0. So our axis of symmetry is going to be x equals 0. Again, it has to be an equation because it is a vertical line. Now this axis of symmetry, this vertical line, is related to the x-coordinate of the vertex. Because when we drew it, we had to start at the vertex and we drew a vertical line through the vertex. So if you know your vertex and the x-coordinate, you're going to know your axis of symmetry or the equation for it. So let's apply some of this knowledge now. We now have a graph that's given, similar to ones we've dealt with in the past. It's asking us what's the vertex, maximum or min, line of symmetry. We're going to find the x and the y intercepts. Use that graph in order to make an estimate and also find the range. So let's start with what is the vertex. We're going to look on the graph, find our lowest point in this case, and determine what the vertex is. This graph is hard for me to read, so I'm going to start off at the origin, 0, 0, and see, to get to this vertex, we have to go 1 to the right, so that means it's a -1. And then we had to travel down 1, 2, 3, 4, 5, 6, 7, 8, 9. So the numbers you see on the graph are actually below the line. So this is a -9 in the y-coordinate. Now we want to find the axis of symmetry. Using your highlighter or different color, we're going to start at the vertex and then draw your vertical line through that vertex. So the vertical line through the vertex, we know it's a vertical line. It only crosses the x-axis, and I skipped B, but that's okay. It only crosses the x-axis, and it crosses the x-axis at -1. So our line of symmetry is x equals -1. Let's go back and find out the maximum or the min. This is opening upward, and so therefore we are dealing with a minimum or a min. Let's look at the y-intercept. Y-intercept means I'm looking where it crosses the y-axis. Intercept means crosses or touch. So across the y-axis, I know it's y because it says y-intercept. So I'm going to highlight the y-axis just so I can see it a little bit better. Here's my y-axis. It's labeled at the top, has the numbers to the left of it. And we want to know, where does the parabola touch this line? that I have highlighted. So the parabola touches it right at this point. Call that the y-intercept. If it touches at that point, we need to name that point. That point, the x-coordinate is 0, the y-coordinate is a -8. So now we want to find what are the x-coordinates, the x-intercepts. So again, because it's an x-intercept, intercept means touch or cross, so I want to find out where does it touch or cross the x-axis. So I'm going to highlight my x-axis again just so I can see it. It is labeled, and it's the one going left to right. And I want to know, where does that parabola touch or cross the x-axis? It touches in two spots. There's one point here and one point here. I'm going to draw me a little line over here. Let me know. These are my x-intercepts. So to name those as a point, the x-coordinate is -4, y-coordinate 0, and my second point, the x-coordinate is 2, y-coordinate 0. F says, what is the best estimate of a positive value of x for which the function equals -5? So we need to figure out what is it asking us to find. We need to find the best estimate of a positive value of x. So we need to find a positive value of x. When you give us the other information, the function equals -5. So if I say the function equals -5, that's the same as saying y is equal to -5. So let's look. Where is y equal to -5? Using my highlighter again, I'm going to go on the y-axis where I have y is equal to -5. If I draw me a line until I touch the graph, that'll show me the points where y is equal to -5. So I have 2 points where y is equal to -5. I need to know what are the x values. And if they aren't perfect points, the great thing is asking us to estimate it. So to find the x value, I'll go on up and see what is the x value here. And there our x value is -3. So one of the x values is -3 when y is -5. And then I'll look at my second one going on up. The x value is a +1 when y is equal to -5. So now I need to answer the question. The question is to find the positive value. So the only positive value of x is x equals 1. The x equals -3 that's a negative. We do not want to use it. Lastly, let's look at what is the range. Again, it's going to come back to using our vertex. Our vertex was -1, -9, and we knew it was a minimum. So that means all our y values are going to begin at -9, but all the y values are going to be bigger than that in order to graph a parabola opening upwards. The y values have to be bigger, so I'm going to say y is greater than or equal to -9. When we look at problem number 3, we now have a graph. This time we have the graph is titled with time that's in seconds. That is our x-axis. Our y-axis represents the height in meters. So now we have a graph. Notice that so when I do the answers here, I'm also going to ask some questions in which questions could be asked with graphs like this. First, we notice it is a parabola, so it's wonderful. We're looking for the maximum point. That means we're looking for the vertex. So first off, this one's asking for a maximum, and it's meaning what is the vertex? So looking at the vertex, we have our peak, and go down and find the x-coordinate. So the x-coordinate is 4. The y-coordinate, notice it is not, it looks like it's halfway between 130 and 120, so we're going to say the y-coordinate is 125. So questions that could be asked is, how much time needs to pass for this graph to reach the maximum point? And you would answer 4 seconds. Or it could ask, what is the height that will be reached when it reaches the maximum point. And then your answer would be 125 meters. So from this one coordinate, we could ask several questions. B says, what is the axis of symmetry? So using my highlighter, we'll start at the vertex and draw a vertical line that goes through the vertex. Axis of symmetry crosses the x-axis, and it's going to cross at x equals 4. Again, remember how that is related to our x-coordinate of our vertex. What is the y-intercept? I want to know, where is it crossing the y-axis? So I'm going to highlight my y-axis using another highlighter and determining where is it crossing the y-axis. So I see it's crossing the y-axis not quite at 50, not sure if it's equal to 40, so we're going to estimate, and I'm going to say that it crosses the y-axis at about 45. So we get 0 is our x-coordinate, 45 is our y-coordinate. So a question that could be asked here is, what is the initial height that you begin on? And the initial height then, because it's the initial, that means the time is 0, and the height then is 45 meters. And examples of which you can get graphs like this, although we're starting off at 45 meters, so it's going to be a little unrealistic, but I'm not starting off at 0 is what I'm trying to get across, that our initial height is not at 0. So things that can happen where the initial height is not 0 is like when a punter in a football game punts the ball. He is holding the ball, it is not on the ground, so it's not starting off at 0, but the ball will be kicked, it will go up, reach a maximum height, come back down, and if nobody catches it, it will hit the ground. So that's an example of how this graph could have been made. So given time, I'm sure you could also come up with some examples where you wouldn't start off at 0, but you would rise up, come to a peak, and come on back down and then hit the ground. Our next question, D, asks, what are the x-intercepts? So our x-intercepts, again, we're going to look at the x-axis, which is now our time axis. And the x-intercept is where it crosses the x-axis. Well, notice it only crosses at one spot. Since it only crosses at one spot, we only have one x-intercept. It is at 9, and the y-coordinate is 0. So a question that could be asked for an x-intercept, instead of saying what's an x-intercept, the question could be, how much time must pass before it reaches a height of 0? Again, if y is my height, then the height is 0, time is going to be 9 seconds. E says, what is the best estimate of the largest x value for which this function equals 80? So again, what are we trying to find? We're trying to find the largest value of x. I want the largest value of x when my function equals 80. Well, if I'm looking for x, then what I'm given has to be the y. So y must equal to 80. So let's look back on our y-axis and find 80. And then I'm going to go across until I find where it hits the function. Well, here's one spot, but if I keep going, I will see it hits the function at another spot. So there's 2 spots in which the y value can be 80. So now I need to figure out what's the x value. So starting with the first one, moving on down, we see that x is equal to 1. Looking at the second spot, moving on down, we see that x is equal to 7. But what it asked us to do was to find the largest value of x. So the largest value of x would be the x equal to 7. Again, another type of question, instead of what's the largest value of x, that could be asked is, how many seconds does it take in order to reach a height of 80? 80 is our height. How many seconds would it take? Well, it would take 1 second, and it would take 7 seconds. So our last thing to find is the range. In this case, This has a maximum. So we're going to use our vertex again. We know we're looking at y's, and we know our vertex, the y coordinate is 125. So the question is, what's happening with the y values? Well, since it's a maximum, all our y values have to be less than that point in order to graph. So we'll say y is less than or equal to 125. So at the bottom of your page, I want you to summarize what we have done today, which is a little bit new. One of the things that we did, because how did we analyze it? One, we used the axis of symmetry. And we learned that it goes through the vertex, and that it's a vertical line. I'm just going to draw me a vertical line. The other thing that we did was we were able to use the information that was given in order to find what we needed by just using the graph. I'm not sure how to write that, but if I was given an x, we can find y. If you were given the y, we can find the x. We also had to find our, let's make some dots. We also had to find our x and our y intercepts. Okay, this concludes topic 15-3.